All right, well, hopefully you did well on that quiz. We have just a few minutes remaining here. I may go slightly over the bell, but with a test tomorrow, I don't care. But I'm going to try not to go over by too much for your next class's sake. Gavin, Brecken, any students watching, I want you to get out quizzes 29 and 30. So you may have to reach out to parents for this, but you're going to need quizzes 29 and 30. We're going to go over those as part of our review. So pause the video here. Make sure you have those. So as I'm going over stuff, you're remembering and seeing what we're talking about. All right, students in here, quiz 29. Remember, a number in a sequence is called an element, and that's asked there in number 2. We've got vertical and horizontal arrangements. Number 1 asked, what do we call a vertical arrangement, class? Column and horizontal arrangements are called rows. The matrix number 3 references matrix A. What are the dimensions of that matrix, class? 2 rows, 5 columns. So we'd say it's a 2 by 5. Written 2 with a multiplication sign 5. It's a 2 by 5 matrix. Number 4 asked, what's the value for element A14? And that's the 7, remember, because the first row, 4th column is position 7. Remember all of this? Coming back to you, it's been a while. And then the number 13 is in what position there, no, class? A25. A is the name of the matrix, but we use lowercase for the element letter. And then 2, 5, because it's row 2, column 5 is the last value. Can a 3 by 4 matrix be added to another 3 by 4 matrix? Yes, in fact, that's all it can be added to. Remember, to add matrices, they must be the same size. Drop down to number 10. Can I add those matrices? Yeah, because they're the same size. How do I add matrices? It's easy. I just add the matching spots. So in number 10, the 4 and the 1, the 3 and the negative 6, the negative 5 and negative 2, the 2 and the 2 just get added together. Remember, adding matrices. By the way, subtraction is adding the inverse, or the additive inverse, right? Where we would change all the signs in the second matrix and just add the corresponding elements as we go. Number 11, by the way, it's not just a subtraction. There's a negative 5 being distributed to everything. Anyone remember what we call that, where we multiply a value times everything in a matrix? Scalar multiplication, where we multiply the negative 5 by everything and then add that 3 by 3 to the first 3 by 3. Was what we did there on 11. Number 7, jumping back up, true or false, a 3 by 4 can be multiplied by another 3 by 4. False. Okay, so quick refresher here. Remember, for matrix multiplication, the inner dimensions have to match. The outer dimensions tell you what your product is going to be. So a 3 by 3 can be multiplied by a 3 by 2, and you're going to wind up with a 3 by 2 for the answer. You had something like this there on number 12 on the quiz. Number 12, you had 2 matrices being multiplied together. But could they be? Well, what's the dimensions of the first one? 4 by 2, and the second one is 4 by 3. Do the inner dimensions match? So there we would have just said not possible, or can't be done, or no can do, something like that. Looking at number 13. Well, there again we're asked to multiply. What's the dimensions of the first matrix, class? 2 by 3, and the second? 3 by 1. Could those be multiplied? Yes, and my answer is going to be a 2 by 1 matrix. Quick refresher here. Let's say we had a 7, 2, negative 5, 1, 3, 4. Dimensions, class? 2 by 3. And let's suppose we had a 1, 2, 4, 5, 8, negative 1. Dimensions? 3 by 2. Can I multiply those? Yes, and the resulting matrix is going to be 2 by 2 square matrix. Remember, when you do it, my recommendation is figure out the product dimensions and set up a grid work. Sorry about that. Set up a grid work you can use. Remember, you're going to take the row and you're going to drop it down the column so that 7 times 1, 2 times 4, negative 5 times 8. Then you're going to take the same top row, because we're still in the top row, we're going to go to the second column. Drop it down here now. 7 times 2. 2 times 5. Negative 5 times negative 1. And you're going to add the partial products together to get the first 2 terms of the final matrix. So what is that? Negative 25 and 29 when you add those together. Then we're going to take the, it was fitting, then we're going to take the second row. Drop it down the first column. 1 times is 3 times 4 is and 4 times 8, 32, and that ends up giving us, what, 45? And then we're going to go to the next row, or next column. Class? 1 times 2?
2.
3 times 5?
15.
And then
Negative 4.
4 times -1, -4, and that's, what, 13? And there's our answers. Remember that now. If not, go back and find the YouTube video where we talk about matrix multiplication. That's all we, oh, and then the identity matrix. I don't think identity matrix is on the test. That's a little bit deeper. I'm just testing the basics of matrices on the test. Set that quiz aside. Get out quiz 30. Remember solving systems of equations using matrices. We would use an augmented matrix, remember. So as you're looking at the quiz, we would have a 4, -3, 1, and there'd be the vertical line, remember? And we put the, in fact, let me put that up here. I think it might be solvable, I'm not positive. So we would have 4, -3, 1, and we'd have the line, remember where the equal signs were, we'd put a 12. 5, 2, -4, -3. 1, -1, 3, -1. Remember how to make an augmented matrix from a system. What's the first key? And it's on the poster. What's the first key to solving the system using the matrix? Gotta get a 1 in this first spot. Well, there's an easy way to do that right now.
Switch the rows.
Just put that right up there, correct? I could just move this so the 1, -1, 3, -1 is in the top spot. And then the 4, 5, or 4, -3, 1, 12, and 5, 2, -4, -3 are in other spots, right? But I've got the 1. The next key is to get a little triangle of zeros. These numbers need to be zeros. Let's start by getting a 0 right here, though. What would be the best way to do that? Temporarily put a -4 through the top. To temporarily get, and I'm off the screen again. I'm going to come back over here. -4, 4, -12, 4. And put that with the 4, -3, 1, 12 to get what new second row class?
1, -11, 16.
There we go. So I'm going to really keep the 1, -1, 3, -1. For now, I've got a 0, 1, -11, 16. And then to get a 0 right here, top by -5 now. So my temporary top row, and then of course the bottom row is the 5, 2, -4, -3. That gives me what new bottom row?
0, 7, -19, 2.
I'm beginning to wonder if this thing actually works or if I just made up a random system that I never intended to solve. The last thing is I gotta get the 0 here, but I've got to use which 2 rows to make that happen? The bottom 2 rows have to be the ones I use. So that means I'm probably going to need to multiply a -7 through the middle, temporarily, of course. So I'm really going to keep the 1, -1, 3, -1. I really am going to end up with the 0, 1, -11, 16. But in the bottom, the middle row is temporarily going to become class -112. And then my 0, 7, -19, 2 gives me what actual bottom row now? 68, 58? 58 and -110. This was clearly never intended to be solved, but at that point, I would put in my 0 or my z and my equal sign. I would divide both sides by 58, hopefully to get an integer. It will be on the test. You take that integer, plug it in here, put a y and an equals, solve for y. Plug in the z you found, the y you found, put in your x and your equals, solve for x. Again, if you need to go back and rewatch some videos, the beauty of it is you can, but hopefully that refreshes your memory on matrices. Everything that would be on the rest of the test we went over in some form or fashion in the last 2 days. Do what you need to be ready for this test. No homework this evening other than get ready. You are dismissed.